Hello, my name's Fred Jensen, and I'm a petrophysicist with CGG Geosoftware. And I'm here to talk to you today about petrophysics and modeling for geologists. One of the problems our industry faces is there's a shortage of petrophysicists, and the ones in the industry we have now are largely old and grumpy like myself. Very often, and I'm seeing this more and more, companies are turning to geologists to do their own basic petrophysics, to compute porosity, water saturation, and generate some maps. And so we're going to talk about PowerLOG, a product of CGG Geosoftware, and how it can help geologists in their day-to-day work where they can do some of the basic petrophysical work and not rely on waiting for that grumpy old man sitting in the corner. So let's go ahead and get started. So PowerLOG is a very powerful software suite. It's very fast. It allows people to collaborate. And it's a high-quality application. It was first released over 35 years ago and has been an industry leader and a standard in the field of petrophysics ever since. We're now running PowerLOG 9.0. It's the newest release. It's very intuitive. It's the most intuitive and user-friendly package on the market today. That's what makes it so applicable to geologists. We have Faces ID, which is a great tool. It is really the most interactive facies classification where you go in and you define the centers of your n-dimensional clusters, and it computes the facies for you, and you have just total control. Very interactive, very, very user-friendly. And we also have a product called Earth Model Builder that one of our modelers will be talking about actually later in the presentation. It allows you to build your 3D models, and it's a very nice geomodeling tool. So speed. Import and export functionality is really important, and that's something that PowerLOG dominates in our field. We have the best importers and exporters. You can load your wells very quickly. You can execute your interpretation. You can determine all your facies. And then you can generate a model fast. And that's something that we're all interested in doing. And one thing this PowerLOG allows you to do, because we're running on an object-oriented database, and we keep track of users and roles, we allow collaborative environments where geologists, petrophysicists, and all engineers, they can work together on multiple wells, keep track of their interpretation, and it's designed to be a very efficient process. So PowerLOG is sitting on a powerful commercial database. We're sitting on objectivity, and we're constantly looking at staying on the leading edge of technology. So we're moving we're looking at research projects. We're actually doing research projects, looking at cloud-based technologies and really esoteric things like Hadoop. But it's not critical for you, but it's important for your IT department. And if you come to understand that PowerLOG stays pretty much on the leading edge of database technologies. So we have a centralized data management. That's very important. You can automate your backup and restore so that you don't lose any work. And it keeps track of where all your wells and where all your interpretations are. We have query tools. If you ever tried to work with a large group of wells, like over 1,000, and you do not have the ability to query the database, then it's a very inefficient way of working with large data sets. We can allow you to set up corporate standards for display and processing. So every one of your resistivity logs will have the same colors and scales. And you can set up standard processing workflows that everybody will follow. And it's very useful for being able to compare one person's work with another if you're all following the same standards in processing and displaying data. And it's multi-user, multi-interpreter. And that means that if you have a partner, you can bring in their interpretations, but you can keep them separate from your interpretations. And you can look at what your partner's doing and compare it to what you're doing. That's just one example of how useful multi-user, multi-interpreter functionality can be. So it's a streamlined workflow, so let's go through it real fast. So you're going to batch load the data. You're going to take a look at your well locations and make sure they're in the right place. You don't want it to be where your well data is on Mars and your seismic data is on Venus. Then you can process the data, create all your zones, do your interpretation analysis, display your results, and hand all this over to the modeler who will be generating the model. So for batch loading data, we have a bunch of data loaders. We have well header loaders, LAS and run, we have DLIS, we have all kinds of data loaders. We have a deviation survey loader, which is very powerful, and it's actually an Excel loader that loads all kinds of Excel data. And we can load the well kits. So here's the well header data. These are smart data loaders. And by that I mean if you have a file you want to load, and the column header in the file actually matches one of the objects in the database, it'll link them up automatically. Otherwise, you just match you want to use the API for EWI, the operator matches exactly, you want your well name, well number, and then you just match the item to the database. Then you can save this so that if you ever have to map a file from this, load some data from the same source, you just bring back your format and load it automatically. Very interactive, very easy to use. And then you can go check it. And that's always a lot of fun. We have Google Maps where you can go in and bring up your Google Maps and post all your well locations. And I don't know how often Google Map updates their satellite imagery, but I have yet to find a well, unless it was like 90 years old, where I couldn't see the location. And even some of these wells are quite old, and you can still see the remnants of their locations. And that allows you to validate that you have your data in the right place, although some of these wells I might want to move a little bit, like this one right here. And we allow you to just grab it, drag it, and drop it, and adjust the XYs in the database interactively. You can batch load all your LAS files, so you can load hundreds of LAS files in just a few minutes and populate all your wells with turn data. Here's an example of where you're batch loading your deviation surveys. You got this big Excel spreadsheet with, in this case, I believe it had 77 deviation surveys on it. You build a format, it applies them automatically. It splits the 77 into 77 virtual files and loads away. Really slick, really easy data loading. And then you can bring in all your tops. Notice how all these data loaders look a whole lot alike, and they all have the same look and feel. So once you've learned how to use one data loader, it's very easy to learn to use all the data loaders. So here we're loading in the UWI, top name, depth, and if we wanted to, we could specify who the interpreter was. In this case, we'll just let the owner, the loader, be the interpreter, whoever did the data loading. You can also go into all this, the database, and you can associate files, maps, any kind of information, digital information, with either your wells or your project. So you could bring in hand-drawn base maps, satellite imagery, mud logs, drilling reports, any kind of test data, and you can store it in the database and recall it when needed, and you can associate it with either the project or the wells. It's a very handy way of managing all of your data that's associated with the project. So now let's go ahead and process the data. So I've loaded in, I've got 1,310 wells, but I'm not interested in every well. I just want to take a look at the wells that have curve data. So I go to query. It says I got to have at least a gamma ray in the row B. And then I run a query and I get a list of 192 wells, and I save this query and create a well list. And now I can operate from that well list. And that's an example of how useful queries can be. I'm going to batch process all of my deviation surveys and generate well paths for all the wells. I'm going to do it for the deviated wells, and I'm also going to do it for the vertical wells, since we need to have defined borehole paths for our modern software. So here we have our input curves, and we actually will go to the database and pull information like total depth driller and datum, so that you can actually do a batch process and process multiple deviation surveys at the same time. You have the ability to QC, edit, and add pics to wells, and it's really a nice way to do it, where you can bring up your type log, and this is the well that we're confident the tops are right. And then you can just drag and drop wells into another log view and you can adjust your tops. You can drag and drop your tops. So you can go through and you can QC your interpretation and generate new tops in a very quick, interactive way. In this case, I went through about 165 wells and validated, added, edited tops in about 2 hours. So it's much faster than trying to do it, say, on paper using spreadsheets. A whole lot better than that. Now we're going to create the zones, and we do that by building what we consider a pseudo-strat column, where we go in and we define all the zones in the well, the F1 and the F2 being the main zones of interest, and we define the top and the base. And if there's a case where it's a little subtle and you might have a second choice for the top and a third choice for the top, you can set up some fairly sophisticated methods of generating zones. You run on every well with curve data, and we made that well list earlier, and it creates all the zones for you. So now you've got all the zones defined. Now you want to do your interpretation and analysis. So we're going to perform the basic log interpretation. We're going to use quick look. We're going to do a zone null value analysis. Very often, even though you have the zones in wells that have curve data, the curves don't cover the entire well. And so part of the well will have null values, and that can really mess up your analysis. So we'll show how to quickly visually see that and get rid of those wells. And then you'll generate a pay zone analysis. So here's the interpretation. We run quick look. Very nice, very well organized module where you just put in a few parameters. We're also dragging some parameters from the database, like the resistivity of the mud filtrate, the temperature of the mud filtrate. And we're going to calculate a water saturation and a V play and get all the parameters we need. We're also going to generate a permeability using a user program, very easy to do. So now we have all the data. We can run this at all the wells that have the density curve, the F1 and the F2 zone. One of the things we want to mention is that PowerLOG has journaling that allows you to go back in and reproduce exactly what you've done. So if you go back like an hour later, in my case, and you forgot what the RW you used, you can go back and check what parameters were used, how you did your VCL, what your RW was, what the temperature of RW was, and really understand how all the curves and all the wells and all the information was generated. Very nice journaling. So now we want to run an analysis, and we're going to go in and we're going to use water saturation, porosity, volume of clay, and permeability to define our pays, and we're going to use the F1 and F2 zone, and we're going to work over those two zones. Here are the two zones on one of the wells. Now, before we go in and do the full analysis, though, we want to make sure that the curve data is continuous across both the zones. So we looked at the F2, and we noticed that these zones, these 1, 2, 3, 4, 5, 6 wells, actually do not have continuous curve data. Some of these have, less than 20% of the well cover. And so we're going to eliminate those wells from the analysis. And if you look right in here at the analysis, you'll see that we've got some funny-looking bubbles and stuff. Once we eliminate these curves that have null values, we get a much more geologically reasonable interpretation of the hydrocarbon pore volume. And then we can display the results with contours and base map. So here's the hydrocarbon pore volume of the F1. And you notice you've got a whole lot of pay down in here. I mean, a lot of pay, up to 12 feet of hydrocarbon pore volume. You go to an area with very low pore volume, and you come back and you see we're approaching an area that has higher hydrocarbon pore volume up here. So it's a highly variable pay section in the F1. The F2, however, is much more continuous. It has a lot of hydrocarbons down here, but you have pay pretty much spread. You still have a lot of pay up in here. And here's what the F2 zone looks like. If we generate a pseudo cross-section with collage through the F1 and F2, you can see that the F1 is highly variable. There's that pay that we were getting into up on the northwest side, And you can see moving through this interval, there's almost no pay, and then the pay builds up quite dramatically. Whereas in the F1 section, it just kind of thins as you move to the north, so that you get a little bit less pay in the F2, but you have a pretty continuous section. So now you want to generate the 3D models of the reservoir property, but before I hand it over to my partner in crime, I'm going to show the facies classification which we generated that they wanted to use in their reservoir modeling. Every modeler I've talked to always wants to have at least the sand, the shale, and the silt. So we're going to generate those using the facies classification module. And the way it works is you can do it in your cross plots, or you can do the log plot. You can go in and say, that's a sand. You click it, you go over and you tell the module it's a sand, then you go click it, you go tell the module it's a silt, you go click it, tell the module it's a shale, and then it'll generate the rest of the facies, and you can actually interactively pick them on your cross plots as well. And it's the most interactive, user-friendly way there is to generate facies curves. And with that, I believe I'm going to hand that over to Rob Shellac, who's going to take over with the modeling part.
Well, thank you very much, Fred. I appreciate you passing that over to me. I am Rob Shellac. I am a geomodeler here at CGG, and I want to continue on with the work that Fred did moving into the geomodeling area. So here at CGG, I'm very fortunate to be able to work with somebody like Fred, who is a very experienced petrophysicist and can provide me with all the available information I need to move into the modeling world. What I'm showing here on this first slide is the new launcher that we have in JSON 9.0. We have the ability to launch PowerLOG Enterprise, JSON Workbench, and Earth Model FT under one application. And I'll get to exactly why that's important because, again, we're going to be working off a common database, a common data model, where all the data is shared between all of these applications seamlessly. So in the past, what I would have to do is I'd have to have somebody export the wells and logs out in LAS files. Then I'd have to re-import them into my modeling package. And if I found errors, it was back and forth a round trip to go back, clean it up, and then re-import the cleaned up data back into my system. So with this new integration that we have seamless integration of all of our data where we don't need to do transfers. It's all there available. So if something changes, I automatically see it, I get it, I have instant updates to my reservoir model, which I'll talk about a little bit later. So again, you'll see here on the slide, we have a launcher, we have some information being displayed. These are all the tools that are started from the actual GeoSoftware launcher that we have. So you can query and look at the data multiple ways. You can look at it in PowerLOG, you can look at it in the GeoSoftware launcher. We have tools there to investigate and query your information. And we also have the same tools in Earth Model FT to do it there. So it depends on where you want to do stuff, but you have access to all the same data. So within the launcher, you can start the various applications, you can create your database, you can manage your data, and all the data loaders that we have now have been moved out of Earth Model FT and moved up to the main launcher. So we now have a single set of tools for loading all your well data into the database. Again, we have visualization tools so you can look at and query and understand your data, and then you can then edit this data if you so desire in the various packages that we showed you. So what is Earth Model Builder? Well, Earth Model Builder is a GeoSoftware application that allows you to build geomodels and distribute properties from well log data within the models. The system allows you to build quick, first-pass models with less time and effort so you can understand your reservoir, understand maybe your data, query and QC maybe problems. Like Fred said, he had 160 wells and he interpreted them in a few hours. But sometimes we, as modelers, we see information that comes across that you have a lot of information. You need to look at all the information in detail. Sometimes data passes through, but in the 3D model, you will see bullseyes. You will see things that stick out at you that say, there's something maybe wrong with this data. Maybe it's shifted slightly. Maybe it hasn't been normalized quite right. So again, why just make 2D maps when you can do stuff in 3D in about the same amount of time with less effort as well? So again, fully encompassed three-dimensional modeling package linked to all your well data. So with Earth Model Builder, we improve your efficiency, accuracy, and flexibility in building models. You can set up different wells and logs with different information, and you can populate that log information into the models very quickly and try to optimize your field development plan and your well planning processes as well. Again, we developed a new user interface last year, and teams have been using that, and they've been actively working with this new user interface. It's very easy to understand where the data is. Everything is nicely laid out in the data tree, starting with your stratigraphy, your wells, the geometry, moving down into the 3D model, and then all your visualizations are also stored in the data tree. So everything's accessible through the data tree. We have multiple views that you can use to view the information in 2D and 3D. And again, it's all integrated into one system for you, so you can do fast, efficient modeling through the reservoir description. Part of the effort that we went through with Earth Model Builder is try to reduce the cycle time. Again, like I said, if I find an error with one of my wells and logs, and I go back to maybe Fred, or I decide I want to go in and just make a quick change, I can go back to the database, make a quick change to that well or log. But then for most systems, you have to go back, reincorporate that information into your modeling process, and rerun and rebuild. Well, with Earth Model FT, what it does is, because it's actively connected to that database, it's checking, and it's looking for changes. So when you do make a change in the model, the system notifies you very quickly, hey, this particular well, this particular curve has changed. You may want to do an update. And very quickly, all you have to do is go over one of these areas here where you see the little U's, the red U's, right-click on that, or select multiple, right-click on it and say update, and the system will run through all the steps that are required from the beginning of the workflow to the end of the workflow to incorporate all the changes that data was used in your modeling workflow. So again, you don't have to go back, regenerate the workflows. You don't have to go back and figure out which ones do I need to change, which ones do I need to rerun. The system is recording and understanding all the steps that you went through to get to that final maybe volumetric number. And if that piece of information started at the very beginning, it will rerun all of the processes to get to that final result for you. So again, quick results, fast, where you don't have to worry about understanding what steps or what jobs did I use to get there. Again, with the QC and Earth Model FT and PowerLOG, we have various viewers and various ways to look at our information. We have multi-well viewers, we have tables and grids, and again, all this is all interconnected. So if I go make a change in a table, in a view, in a color scale, if I make a change anywhere, that change is reflected in all of our applications. So again, it's a one-stop shop for looking at your data, making changes, and it's reflected in all of our applications seamlessly. So that makes it very efficient and very effective, because if I change a color in one application, it doesn't look the same in the other one, you have to go change it again in the other application. No, we've taken care of that for you. Again, with the integration of PowerLOG, again, you can create multiple well log curves, like I said earlier. So if you decide, I want to try maybe a neutron porosity, density porosity, I want to populate those in the model just to understand or see maybe what the differences are in those different calculations. You can run multiple scenarios. And again, with updatability that I showed you before, you can create those different models, run updatability, make changes to those curves, and again, everything will be updated for you automatically. So it allows you to very quickly integrate everything, interact with everything, and come up with various scenarios to better understand your reservoir and how it's going to be affected through your reservoir simulator. So again, kind of in summary, with Earth Model Builder, you have lots of data loading and QC options. You can run histograms, cross plots, you can make 2D maps, you can look at three-dimensional views and two-dimensional views, you can distribute deterministic properties, like Fred says. Us in the geology world, we like to have a phases. We like to populate things by property, rock property, discrete properties first, and then within that, distribute our porosity and permeability to come up with a volumetric number. And then with updatability, we can quickly make changes to those data distributions and input data to automatically update our data. And here you can see what Ben was talking about, that F2 unit. You can see that nice high porosity streak that we have at the F2. The F1 above that is not as good. You can see that the porosity range is much tighter, much lower in that area. So again, we've really optimized the workflow between the geologist and the engineer and the petrophysicist, where we have fully easy-to-use workflows, streamlined processes, where you can look at all your information, interact with all of it all together, and you can get more better results, more complete results from beginning to end. We thank you very much for coming and listening to our talk, and we hope this was informative. Thank you very much.